All right, so we are given this function, and in part A, we are asked to find the slope of the line tangent. So when it's talking about slope, that means we are taking a derivative. So you could do this two different ways. I'm just going to do quotient rule with it. So we do low 2x squared minus 7x plus 5. D high is 0 minus high. D low is 4x minus 7 all over the denominator squared. So that really all just kind of goes away. So we're trying to find the slope at 3. So that's going to give us negative 3. 12 minus 7 is going to be 5. Then we're going to plug in 3 down here. So 3 squared is 9 times 2 is 18 minus 21 plus 5 squared. So we're going to get negative 15. So 18 and negative 21 is going to give us negative 3. Plus 5 is 2. Squared is 4. So that should be our slope of the tangent line, and that's all we got to do for our part A. Now for part B, we want the x-coordinate of each critical point, and we're going to classify it as a min, a max, or neither. So critical points deal with our first derivative. So I'm just going to simplify this a little bit to negative 12x plus 21 over 2x squared minus 7x plus 5. We would set that equal to 0. So when we go to solve that, we would multiply by the denominator, which just gives us this. So we would get 21 equals 12x, and then 21 divided by 12 should give us 7 over 4. So 7 over 4 is in our interval. So now we need to check and see what happens around this. So we need to check a number bigger than 7 over 4 and then a number smaller than 7 over 4 and see if it comes out positive or if it comes out negative. So if we look at something bigger than 7 over 4, that would be like 2. So if we plugged in 2, the denominator is always going to be positive because it's squared. So we're really only concerned about the top. So if we plugged in 2, negative 12 times 2 is negative 24, plus 21 is going to be negative. So that means it is decreasing there. Something smaller than 7 over 4, since we're restricted to that interval, I'm going to go with 5 over 4. But that is going to come out positive regardless of what we pick. So we're going to classify it as a min, max, or neither. Since it changes from positive to negative, it's a maximum, and so that's exactly what we're going to say. F prime changes from positive to negative at x equals 7 over 4. So x equals 7 over 4 is a maximum. And that is our only critical number because that's the only place it equals 0. Now on our part C, it is having you integrate an improper integral. And they did the partial fractions work for you right here already, which is very nice of them. So with an improper integral, we don't want this infinity in the top. So we want to rewrite this as b approaches infinity of the integral from 5 to b of 2 over 2x minus 5 minus 1 over x minus 1 dx. So with improper integrals, we evaluate each integral, or we evaluate the integral, then we evaluate the limit. So this right here, this first part of it, you could do a u substitution with it. You would say like u is equal to 2x minus 5, du is equal to 2, and you have everything you need. So that would come out to 1 over u, which will come out to ln. And so you would plug the u back in. So that would be 2x minus 5 minus, this has a 1 on top, so it's easier, ln of absolute value of x minus 1. And that's evaluated from 5 to b. Now, when you can combine them, you should, since these coefficients are the same. We're going to get 2x minus 5 over x minus 1 because those natural logs are subtracted from each other. So now we can plug in the boundaries for our integral. So ln of 2b minus 5 over b minus 1 minus ln of 2 times 5 is 10 minus 5 is 5 over 4. So now we go to evaluating the integral, or not the integral, the limit. So we're looking as b approaches infinity. So when you have a function, we want to look like inside out. So this inside part is balanced because it's b on top and b on bottom. The coefficient on b on top is 2. Coefficient of b on bottom is 1. So that means this is going to come out to ln of 2. And then this part doesn't have any b's, so we're just good there. So you can leave it here. You can combine it a little bit further and say that this is the ln of 2 over 5 over 4, which means it's the ln of 8 over 5. And that does mean that it converges. Now for part D, it says determine whether this series converges or diverges. And then we're going to state the conditions of the test used for determining convergence or divergence. I'm going to give you 2 options. The easiest test would be the integral test, because we actually just did that in part C. So for the integral test, your function needs to be decreasing and positive. And that is the case with this function because as you plug in bigger and bigger numbers, the denominator is going to get bigger, and so that means it's always going to get smaller and smaller and smaller. And so if the integral converges, then the series converges. And so that is what happened in part C. We saw the integral converges, therefore in part D, the series is going to converge. Now the integral test was not your favorite, so you may have wanted to use the limit comparison. So when you do the limit comparison, if you do the limit as n approaches infinity of some series a sub n over some series b sub n, and you get an L, where L is finite and positive. That means they behave the same. So I would compare this to 1 over n squared because our power on the bottom is n squared. And 1 over n squared is a convergent p-series. So if we do the limit as n approaches infinity of the function we're given over the one we're comparing it to, that's going to mean we're going to have 3n squared over 2n squared minus 7n plus 5. That's balanced, so that comes out to 3 over 2. So that means this will converge because 1 over n squared converges. So if you guys have any questions about this video, please let me know. But we will start reviewing for your AP exam next week. Thanks, guys.